Let's look at a few more that are not quite so straightforward. So here we have a product of our x minus 2 and our 2x plus 3. So before we try to tackle the derivative here, let's FOIL this and let's get it to where we do not have that multiplication of the terms anymore. So if we FOIL this, we'll have x times 2x. That will give us 2x squared. We'll have x times 3, so that will give us plus 3x. We have negative 2 times 2x, so minus 4x, and negative 2 times 3, so minus 6. So cleaning that up a little bit, we get 2x squared minus x minus 6. Now we can take our derivative. So if we take our derivative, 2 times 2 gives us 4x, subtract 1 from the 2, so that would just be to the first. This is technically x to the first right now, so bring down your power, subtract 1 will be x to the 0. The derivative of a constant, which negative 6 is a constant, is 0, so our derivative will be 4x minus 1. Now let's look at the next one. Here we have e to the power of t. This is special. When we have a derivative, we are always trying to be careful to follow our special cases, and e to the x is a special case, or e to the t in this one. If it is just e is just a number. But if it's e raised to the power of the variable, well, then it is special. The derivative of e to the x is e to the x. So the derivative of e to the x is e to the x. Well, in this case, we have e to the t because our variable is t. So the derivative of e to the t will be e to the t. So let's go ahead and take our derivative. So we have h prime of t equals, we have 8t to the second. So we bring down our power, 8 times 2 is 16. And we had to the second, so we subtract 1, so it's just to the first power. Then we have plus 2t, so the derivative of 2t is just 2. And then we have minus e to the t. The derivative of e to the t is e to the t, so it'll look like this. Number 8, to simplify this one, we can divide everything through by that x that we have in the denominator. If we separate our fraction, it'll look like 7x squared, and then we have our minus 3x, and we have our plus 5. And we can put those all over what we have as our common denominator of x. Now we can simplify this. We can say that y equals 7x squared over x is just 7x. Negative 3x over x is just negative 3. And then we have our plus 5 over x. Well, remember, if the x is in the denominator and you want to move it to the numerator, you can use your negative exponent. So this will look like 5x to the negative 1. So we can take our derivative. To take our derivative, we bring down the power and subtract 1. Well, this was x to the first, so the derivative of 7x is just 7. 3 is a constant. So we have our minus 3 right here, so that's minus a constant. So that is just going to be 0, so nothing there. Here we have our 5x to the negative 1. So if we bring down our power, we'll have 5 times negative 1. And then we'll have x, negative 1 minus 1 is negative 2. So this will look like y prime equals 7 minus 5x to the negative 2. You could also switch it to have it as 7 minus 5 and then put x to the second on the bottom. Either way, they're both accurate and they're both correct. Sometimes you don't want to write the negative exponent. Sometimes you prefer not to have the fraction. So either case, either way. Same thing for this one. Let's rewrite what we have. So this can look like x squared over x minus 2 times the square root of x over x. So if we simplify this down, well, the square root of x is x to the 1/2. So we could write this as 2x to the 1/2. Remember that if you have the square root of x, here's the 1, here's the 2, you can switch that to the 1/2 power. And so if we simplify this a little bit more, x squared over x is just x. Then we have our 2 right here. We have x to the 1/2 over x to the 1. So if we simplify that down, that will look like 2 over the square root of x. Or you could say 2x to the negative 1/2. A lot of algebra there, so let me know if you got stuck. So if we take our derivative, y prime, the derivative of x is just 1 because it's just bring down your power. So you have your 1 and then subtract 1. X to the 0 is 0. So x to the 0 is 1. So all we have left is our 1. So for this one, be careful. You had -2. You're bringing down your -1/2 and you have x. And then we had -1/2 and we're subtracting 1. So -1/2 minus 1 is -3/2. And then right here, -2 times -1/2 is going to be +1. We have x to the -3/2. It's a 1, it's an understood one. You don't have to write that. And you could, if you wanted to, switch it to, I'll put an or right here so that you know you can do either. Y prime equals 1 plus 1 over x to the 3/2. If you didn't want to have the negative exponent, you could write it that way as well.